Hey guys, didn't mean to do that. Okay, here's what we're gonna do. So I have like racked my brain trying to figure out the best way to explain the stocks and the percentages, and for some reason I cannot get my brain to put things into words. So I hope that you guys understood that last video that you watched that I just kind of like tagged from. I really like that. I think that his formula is really easy to do and it's easier to understand. There's just a couple things I want you to remember. One is that percentages are always grams per like 100 milliliters or grams per 100 grams. So remember that. The other thing is whenever you're looking at ratios, it's always it's the same idea. So if you go to that ratio dosages on 529, it says, ratios are just like parts, one part to another. But look, it says if the 1 to 10 ratio were a weight found in a volume, I'm on page 529, 1 gram of solute would be found in 10 milliliters of the solution. So it's grams to milliliters, if that's what we're talking about. Okay. Or milliliters to 10 milliliters or whatever, like that one is, milliliter to milliliter. So like 1 part to 500 would be 1 gram to 500 milliliters. So anyways, I just wanted to specify that in case you get, stuck on any of that as you go through. I think that, I think that's going to be your best route, the easiest way to go. I think that his formula is really good. The V1 and C1 is equal to V2 and C2. Just make sure your concentration. Remember that if it's in percentages, then it's your 25%, whatever your percent is over 100. If it's in ratio, then you can just put the ratio in there. If it's a ratio of 1 to 4, it'd just be 1 over 4. Okay. So anyways, you might watch that a couple of times to kind of grasp it and watch what he's doing. I think he does a good job of explaining it much better than I tried to do today. And so we're going to go on, and I'll let you kind of practice that. We're going to go on to this using dilutions with alligations. I think that this is something that we can specifically talk about. It's pretty simple, straightforward to do, and you can actually use alligations for a lot of the problems that you're going to be doing as well. So anyways, it says alligation on 539 is a mathematical method of solving calculations involving the mixing of solutions or compounds that have different percentage strength. So you've got a 50% solution and a 10% solution, and you want to mix them to make a 30% solution. The good thing about this is alligation is really easy to see and play out. I think it's a little bit more tangible for me, at least in my head. And even if you're mixing like a complete solution and diluting it down, it's easy to do that way too. So anyway, because alligation indicates the parts of 2 given stock medications needed to prepare the desired strength. Preparation of diluted compounds from stock medications to meet a prescription ordered is actually accomplished in 2 steps. So we're going to look at this and go from there. So since the final strength of a mixture must lie somewhere between the strengths of the component parts, so you can't use a 50% solution to make a 100% solution, or like a 50% solution to then make a 90%. It's just not, you can't increase the concentration once you've already got that. Okay, so look, it says to begin alligation alternate, think of preparing a box for tic-tac-toe. So that's how you'll set this up. Alligation is you use a tic-tac-toe. And it says, think of preparing a box for playing tic-tac-toe to allow numbers to be placed in the 4 corners in the center box. So this on this hand side is percentages we have. In the middle is percent desired. And then the last little line, the last vertical part, gives us our parts. It's going to give us our ratio parts. Okay, so let's look at this example it gives us. And we're going to go through kind of each little section. So here's our example in 13.9. It says prepare 1 liter of solution of a 70% alcohol from a 50 and a 95%. So we have 95% alcohol and 50% alcohol in stock, but we want to make a 70% one. So if we do, so at the top of our, or in the middle, in the very center box, we're going to put the strength that we want. Okay, so in this case, it's 70. Okay, place the highest percentage concentration in the upper left corner. So that would be 95 here. And then in the bottom corner, we're going to place the lower one. So in this case, it was 50. Now it says subtract the center square from the left upper square and place in the lower right. So you're going to do like tic-tac-toe. So 95 minus 70 is 15. Okay, and 70 minus 50 is 20. Okay, so we're doing our, this way I know it's going opposite, but 70 minus 50 is 20 and 95 minus 70 is 15. Is that right? No. Y'all, oh my goodness, it's getting late. I am going crazy. 25, there we go. Oh. Okay, now it says, step 5, subtract the center square from the left upper square and place in the lower right square. And then 6 is subtract the lower left square from the center. So what this does is this gives us an amount of parts. So basically what it's saying is we need 20 parts to every 25 parts of this solution. So we need to take 20 parts of the 95% solution to 25 parts of the 50% solution in order to get that 70%. Okay, now it says, step 7, it says add the parts of the concentration to find the total parts in the compound. So total parts, okay, are going to be 45. That's how many total parts we have in the concentration as a whole. Okay. So now what we know, it says to prepare the solution, we mix 20 parts of that with 25 parts of this to get our total solution. It says, remember, this is proportional. It must be used to find the exact part amounts when the total weight or volume is indicated. So now it says, using the previous example, the total amount of the solution is 1 liter of 70%. So now you're going to use like, it's like a ratio. This part is going to be a ratio. So the 95% of the 95% solution, you are going to need 20 out of 45 parts to be the 95% solution. And we know total, we have 1,000 milliliters is what we want, or yeah, 1 liter, 1,000 milliliters. So I'm going to put equals X over 1,000 milliliters. Okay, and that's it. So that tells us, what is that, 20,000 milliliters. So we get 444. Okay, that means we're going to need 444 milliliters of our 95% solution. And we're going to mix it with the rest of our solution. So down here I got 25 out of 45 equals X over 1,000. Now it should end up. Okay, so get 555.6. Okay, now a good way to check this is, let me make sure 444 and 555 is definitely close to 999. So yes, so we're good to go with that. And that's pretty much, I mean, that's pretty much it. So that's a really simple way to figure out if you're diluting to stock medications. Okay. Now it says alligation on 542. It says alligation media was a method of calculation that may be used to define the weighted average percentage strength of a mixture, 2 or more substances with known quantities. So when 2 or more solutes must be added to one compound, this method allows rapid calculation. The percentage strength must be expressed as a whole number for each component, and the quantities must be expressed in common measurements, such as the same weight or same volume indicated. If a percentage of the solvent is not provided in most cases it may be considered 0. So if you're just mixing it with something that doesn't have anything, any of the active ingredient in it, then it'd be 0. So what they've done is they've used a, this is just a kind of a shortened, like a formula method on here. So look, they do the amount desired, the milliliters, times the percent in a decimal equals to grams. So look, 1 liter times your 0.7 is 700 grams. And then this is just a way to kind of check it. So 556 grams down here times your 0.5% is going to give you 278. This is at 542. And then the 444 times the 0.95%, that's your concentration. And then all those should add up to equal each other. So this is just a way to show you that it's correct. So let's look at a couple of these. Let's do number 3. Okay, so I'm going to make my tic-tac-toe. Now it says a physician orders 20 grams of a 15% tannic acid ointment. So that's what we want, 15%. Okay, available are 2 tannic acid ointments in 12 and 25. So I'm going to do my 25 up here, 12 down here, and you're going to do your subtraction. 25 minus 15 is 10. 15 minus 12 is 3. So I add these up to get my total parts. That's 13. So I know that 3 out of 13 parts equals X. Out of, we want, how much do we want? We want 20 grams. So X out of 20 grams. Okay. .6 is what we need grams of our 25% ointment. Now down here, we want 10 out of 13. 15.3, 15.4 grams is how much we need of this 12 to mix those together. We're going to get our 20 grams of ointment. Okay. Now we can go back and check this with the medial, like it said. If we do that, then we get our 20 grams times 0.15. That's 3. All right. Oh, here it is. And then let's do our next one, 4.6 times 0.25, 1.15. And then let's do that last one, just like it does on 542, that example where you add up all of that. You've got 15.4 times 0.12, 1.8, 1.85. And so when you add those up, we're going to get 3. Okay, so that's a good way to check that. Now, let me see if I can find a different one in case you get hung up. Okay, let's look at number 11 real quick. We want to change, whenever you see these ratio strengths, we want to change those into percentages. So 1 to 10, the percentage there, of course, is going to be 10%. And then the 1 to 50, of course, is going to be 2%. Check to make sure I've got my yeah. So 1 to 10 is going to be our 10%, and then we've got our 1 to 50 is going to be our 2%. Okay, so that kind of shows you there if you got 10 and 2. I won't work out the rest of that problem. There's a specific one. Look at number 12. Notice that you've got D5, which remember is 5% water, and you've got D10, which is 10%. One thing I wanted to show you, and I don't see any examples on here, but you know, if you, let's say you get hung up on one of your other problems. Let's say you're just wanting to dilute, okay? Maybe you're wanting to dilute a medicine. Something else, okay? Let's say, let's work out one of these old problems from the other section. Okay, so we want to, I'll go back and work out this one. So number 3 on 525 says the stock lotion contains 10% methyl salicylate. How many milliliters do we need necessary to prepare 3 pints of 4%? So let's just figure out how many milligrams we actually need to get there. So we could do, 4% is what we want. And we're going to take our 10% of our other solution, and our base that we're going to end up mixing it with has 0%, if that makes sense. Because in this particular problem, we're mixing a stock medication with some kind of base that doesn't have any active ingredient in it. And whenever we do that, you know, we can figure it out this way too. So this is another way to figure all that out. So 10 minus 4 is 6. 4 minus 7 is 4. Wow, lost my lid. Okay, so over here we've got 10 parts total. Okay, and we can kind of do the same idea here. So of this, our ratio in here is going to be 4 out of 10. And so we want 3 pints. Okay, 3 pints. We figure that into milliliters. I think it's 1440. All right. 480. Yeah, 1440. And so 576. So we need 576 of this solution, and then we would need we can do 6 out of 10 here. Oops. Or we can just subtract our total amount, you know, from there. So here we would get 864. Okay. Yep, 576 milliliters. Okay, so this is another great way. To me, this is like tangible. You can see it. It's a great way to work that out. Okay, so this is an excellent way. Now, you could do this the same thing. If you were to mix, you know, 100% solution with a 0%, I mean, it would be the same thing. Like if you were to mix a stock medication like, okay, like number 7 on here. Look at number 7 on that same page. Ooh. Okay, number 7, it says how many grams of boric acid would be necessary to prepare 16 milliliters of a 5% solution. Okay, if it just says straight boric acid, that means it's 100%. So I'm going to put that up here. Okay, and then we want a 5% solution, and we're just diluting it. So you could put 0 down here if you want to. Okay, so up here we've got 5, here we've got 95. Okay, which this one's pretty easy because you can figure that out. But once you figure out your parts, okay, you got this out of 100, then you can go back and figure out how many to make 16 milliliters. So out of boric acid, 5 out of 100 equals X over 60 milliliters. Okay. Should give us the right amount. Should be 3, but let's check. Oh, I can't check that one on there. But that's another way to do these problems. Okay. So anyways, so that is that. I just wanted to show you guys the alligation method. I would encourage you to just use his formula that he had, the volume and the concentration formula. I think that's a great way to go. Again, only worry about the odd ones that are in here. So we will do that. Okay, and that's it. That is that.